Look at this binomial expansion problem from JEE Main. It looks like an absolute computational nightmare. 2 minutes from now, I am going to show why the final answer is simply 0. We need to find the coefficient of x to the power 5 in the product of 1 plus x whole to the power 7 and 1 minus x whole to the power 3. If your first instinct is to write out Pascal's triangle, expand both brackets completely and multiply them term by term, then stop. That brute force approach takes at least 8 to 10 minutes, and even one single tiny sign mistake ruins the entire problem. JEE test makers set this trap on purpose to drain your clock. Let us dismantle it using a 30-second algebraic rewrite. Here's the master move. Look at those mismatched exponents 7 and 3. Notice that 1 minus x whole to the power 3 wants to pair up with 1 plus x whole to the power 3. So let us borrow 3 factors of 1 plus x from 1 plus x raised to the power 7. That splits our expression into 1 plus x to the power 4 times 1 plus x cubed times 1 minus x cubed. Now combine those cubed terms. We have 1 plus x and we have 1 minus x. That is simply the difference of squares, that is 1 minus x square. So the entire product rewrites into something significantly cleaner, that is 1 plus x whole to the power 4 multiplied by 1 minus x square raised to the power 3. Why is this rewrite so powerful? Look at the second bracket, 1 minus x square to the power 3. Because x is squared inside, this bracket simply cannot produce any odd powers of x. It only generates x to the power 0, x to the power 2, x to the power 4 and x to the power 6. Since we need x to the power 5 and the second bracket only supplies even powers, where must the odd power come from? It has to come from the first bracket, that is 1 plus x whole raised to the power 4. Let us quickly write down 1 plus x whole to the power 4 in the expanded form using the binomial theorem. So we have 1 plus 4x plus 6x square plus 4x cube plus x to the power 4. Which terms here have odd powers of x? Only two of them, 4x and 4x cube. To build an overall power of x to the power 5, these odd terms must multiply with specific even powers from 1 minus x square whole raised to the power 3. Let us expand 1 minus x square whole raised to the power 3 using simple binomial coefficients, that is 1, 3, 3 and 1. So it becomes 1 minus 3x square plus 3x to the power 4 minus x to the power 6. Now let us pair them up to make x to the power 5 using the products. So for the first pair is take 4x from the left and multiply it by 3x to the power 4 from the right. The second pair is take 4x cube from the left and multiply it by minus 3x square from the right. Let us do the arithmetic. The first product becomes 4x times 3x to the power 4 equals plus 12x to the power 5. Second product is 4x cube times minus 3x square, which equals minus 12x to the power 5. Now let us add them together. Positive 12x to the power 5 minus 12x to the power 5 equals 0. These terms cancel out completely. The coefficient of x to the power 5 is 0, not because of a calculation error, but because the underlying symmetry of 1 minus x square forces exact cancellation. What would have taken you 10 minutes of brutal algebra becomes a 30-second mental problem once you recognize how to force the difference of squares structure. Here is your JEE key takeaway. Wherever you see mismatched binomial powers like 1 plus x raised to the power a and 1 minus x raised to the power b, always group matching powers into 1 minus x square first. Separating your expansion into even and odd power groups instantly eliminates half the work. If this shortcut saved you time today, slam that like button and subscribe for weekly JEE Main trick breakdowns. Drop a comment below right now which topics should we cover next week. Complex numbers, coordinate geometry or something else. See you in the next breakdown.